In this video, we're going to talk about solving quadratic equations using square roots. Right? Before we actually get into this, let's talk about what this word means. Quadratic equations. Right? Quadratic equations, the short, quick, easy definition is that these are equations that have a highest power of x squared. Right? So for example, if I had 2x squared equals 7, or 3x squared minus 5x equals 0. Or I could have negative 5x plus x squared equals negative 13. Right? All these equations are quadratic because the highest exponent is a power of 2. Right? So I've got an x squared here, I've got an x squared here, I've got an x squared here. Right? All of these are quadratic equations, and we're going to be working with quadratic equations for quite a bit this year. Right? Today we're just going to barely scratch the surface of how to work with quadratic equations. We're going to talk about one method of working with quadratic equations, which is the method of using square roots. Right? And I just want to point out, this is not the only method of how to solve a quadratic equation, but it's our first one. All right, so we're going to solve this equation. 5x squared minus 31 is equal to 14. Again, this is a quadratic equation because we have an x squared as the highest power of x. All right. So first thing we're going to do is we're going to isolate the x squared. All right. So let's try to get the x squared to be by itself. All right. So I'm going to add 31 to both sides. Right. And I end up with 5x squared plus 0, or just 5x squared, is equal to 45. Okay. All right, next, how can we get the x squared by itself? We're going to divide both sides by 5. Right, so I end up with x squared is equal to 9. All right, and normally, if we had just a linear equation, right, we would be done here. Right? X equals 9. But this is not x, this is x squared. Right? So we got to think, how can we get that x squared to just be an x? Right? And the answer is that we're going to take the square root of both sides. Okay? Now I want you to remember, if we're doing an operation to one side of the equation, in order to keep the other side of the equation equal to the first side, we need to do the same exact operation. Right? So in other words, if I take the square root of the left side of the equation, I need to take the square root of the right side of the equation as well, in order to keep the two sides equal. Right? So let's think. What is the square root of x squared? Right? Well, in a previous video, we talked about how the square root of x squared is the absolute value of x. Okay? And then on the right-hand side, the square root of 9, what's that? Square root of 9 is 3. So we end up with this equation here. Right? This equation, the absolute value of x is equal to 3. Right? And I want you to think about that. What are the solutions to that? Right? Well, this is saying that x, its distance away from 0, has to be 3. Right? What two numbers have an absolute value or a distance away from 0 of 3? The answer is 3 or negative 3. Right? Both of those are 3 spaces away from 0, right? And both of those would make this true. Right? So what's interesting here is that we have an equation that has two answers, right? And let me just prove to you that both these answers work. Or both of these numbers, 3 and negative 3, are solutions, right? If they're solutions, they should make the original equation true. Right? So 5, let's try 3. 5 times 3 squared minus 31 equals 14. Let's see if that's true. Well, here we need to do the 3 squared first. 3 squared is 9, so 5 times 9 minus 31 equals 14. And we get 45 minus 31 equals 14. That's 14 equals 14. That's true. Okay, so it definitely works for 3. Let's see, does it work for negative 3? 5 times negative 3 squared minus 31 equals 14. Right? And you'll find out that this still works. Negative 3 squared is 9, so 5 times 9 minus 31 equals 14. Same thing, 45 minus 31 equals 14. 14 is equal to 14. That is true. Okay. Okay, so there are two solutions, two values for x that make this true. All right, I would like you to solve this one. All right, so please pause and solve this equation. All right, let's check in, see how you did. All right, so first thing, let's isolate the x squared. So I would first subtract 5 from both sides. That gives me x squared over 2 is equal to 32. All right, next, in order to get the x squared by itself, I would multiply both sides by 2. So let's multiply by 2, and 2 is the same thing as 2 over 1, so these 2's will divide out. We get x squared is equal to 64. All right, so now that I have x squared by itself, how do I get x squared, or how do I get it to be just x? Right? The answer is we're going to take the square root of both sides. Right? What's the square root of x squared? That's the absolute value of x. The square root of 64 is 8. Right? So we have this equation here. The absolute value of x is equal to 8. Okay? And so let's think about that. What numbers are 8 spaces away from 0? What numbers have an absolute value of 8? And there are 2. So x could be either negative 8 or x could be equal to positive 8. All right, let's look at another one. We have 50 is equal to 14 minus x squared. Right? So let's isolate the x squared. So first thing I would do is subtract 14 from both sides. And 50 minus 14 is 36. So 36 equals negative x squared. And x squared still isn't by itself, right? We can think of this negative x squared as negative 1x squared. So to get that x squared by itself, I would divide both sides by negative 1. 36 divided by negative 1 is negative 36. So I have negative 36 equals x squared. All right, now how would I get the x to be by itself? What I want to do is square root both sides. All right, let's do the right-hand side first. The square root of x squared is the absolute value of x. Right? And then the left side, the square root of negative 36. It's not 6, because 6 times 6 is a positive 6. What is it? It is an imaginary number. It is 6i. Right? Because 6i times 6i would be negative 36. So we have this statement here. 6i is equal to the absolute value of x. Okay? So what numbers have an absolute value of 6i? There are 2. One would be negative 6i, and the other one would be positive 6i. Right here, this is my answer. All right, now that may seem kind of weird to you, okay, that we have 2 imaginary numbers for answers. But let me prove to you that those are both solutions. Okay? And actually, just for the sake of time, I'm just going to show you one of them, right? And then if you want, you can try the other one on your own. All right, but I'm claiming that both of these are solutions, right? Let me try negative 6i. Let's see if that works. So, let's see, 50, is that equal to 14 minus the quantity negative 6i squared? Okay, so let's see if this is true. So 50 is equal to 14 minus, let's see, what is this going to be? This is negative 6i times negative 6i. Right? Or in other words, we have 50 is equal to 14 minus negative 6i times negative 6i. That's positive 36i squared. We know I squared is negative 1, so we have 14 minus 36 times negative 1 on the right-hand side. And the negative 36 times negative 1 is positive 36. So we get 50 is equal to 14 plus 36, or in other words, 50 is equal to 50. Which is true. Okay, so it's kind of weird, but we got 2 solutions, 2 imaginary solutions. Both of these would make our original equation true. All right, there are 2 more, and I want you to do both of them on your own. Okay, so this one, please pause and solve this one. Let's see how you did. 2x squared plus 48 equals 0. I'm going to subtract 48 from both sides. I get 2x squared is equal to negative 48. To isolate the x squared, I would then divide both sides by 2. We get x squared is equal to negative 24. Alright, let's take the square root of both sides. Let's get some more room. Alright, so the square root of x squared, that is the absolute value of x. Alright, the square root of negative 24, that's not a perfect one, so let's work that out over to the side. Square root of negative 24, let's factorize this. So, let's see, negative 24 is the same thing as negative 1 times positive 24. 24 is 4 times 6. This is 2 times 2. 6 is 2 times 3. So the square root of negative 24 is the square root of negative 1 times the square root of 2 times the square root of 2 times the square root of 2 times the square root of 3. Alright, so let's see what we have. The square root of negative 1, we know this, that's I. Radical 2 times radical 2, that's 2. And then radical 2 times radical 3 is radical 6. So our answer is 2i radical 6. Right, or that's not the final answer, that's the square root of negative 24. Let's go back over here. So this absolute value of x is equal to 2i radical 6. Right? And what numbers have an absolute value of 2i radical 6? There are two answers. X could either be equal to negative 2i radical 6, or x could be equal to positive 2i radical 6. Those are your two solutions. Last one. Again, try this on your own, so please pause. Alright, here's the solution. I'm going to add 6 to both sides. I get 20 is equal to x squared over 3. And then to isolate x squared, I'm going to multiply both sides by 3. Right, or 3 over 1. These 3's will divide out, leaving me with an x squared on the right, and on the left I have 60. Right, once I have my x squared by itself, then I can square root both sides. Square root of x squared is the absolute value of x, and then on the left I need to simplify the square root of 60. That factors as, let's see, 4 times 15, 4 is 2 times 2, 15 is 3 times 5. So the square root of 60 is radical 2 times radical 2 times radical 3 times radical 5, which is the same thing as 2 times the square root of 15. So 2 radical 15 is equal to the absolute value of x. What numbers are 2 radical 15 spaces away from 0? There are 2 numbers. Your answers are negative 2 radical 15, or x could be equal to positive 2 radical 15.